Okay, we're on page 3 of 2.6. And we're talking about domain. So we said the things you need to look out for when you are doing domain is 1, the denominator can never be 0 of a fraction because that's undefined. Our calculator doesn't know how to do it. We don't know how to do it. If we do 2 divided by 0, our calculator say, hey, I don't know how to divide by 0, and neither do you. So we can't let the denominator be 0, and then we'll learn in chapter 6 we can't let square roots be negative, and then in chapter 8 we learn that logs argument have to be positive. So there's really 3 exclusions that we learn about in this class. So what we need to do is look at this fraction and go, what would make this 0? What could I put in for x that would make this 0? So some students like to actually do the algebra, and you could do that. You could say, what would make x minus 7 equal to 0? Because that's what I can't have. So I solve for x using the techniques from your earlier sections that we worked on, and we see x cannot be 7. Why? Plug it in. 7 minus 7 is 0. So it would be fine and dandy if you could circle that and have that be the answer, but look what the directions say. Interval notation, that's the parentheses and the brackets. And remember when we were doing inequalities, I said the easiest way to do interval notation is to graph it. So this right here means x can be anything but 7. So it might be easier to use it. I don't know. So it can be anything but 7. So how do I write that in interval notation? Well, remember when we were doing domain and range earlier, I said you always have to go from left to right when you're on the x-axis. And because there's a gap, 7 isn't included. This is going to be like that one where we did the U. So it'll be this part united with this part, because we can't say negative infinity to positive infinity because 7 had to be thrown out. So on this side, going left to right, we do negative infinity up to 7, but we can't include 7, so we have to use a parenthesis. Remember, a bracket means it's equal to 7. A parenthesis means it goes right up to 7, but it can't be equal to 7. So that's that left interval. This right interval will be 7. Don't let it be equal to 7, comma, infinity. So that would be the domain of that function. And that's just a different way of saying x can be anything in the whole world except 7, because parentheses mean you can't include the 7. It just goes up to 7, but it doesn't ever equal 7. So now that you've seen one done, go ahead and turn off the video and try 7. And like I said, this is more of a topic for chapter 5. We're going to address it again, but these are a little bit easier than 5, so it's kind of nice to start out with some easier ones. Then when we get to the harder ones in 5, you'll have a little background. So I look at this and I go, when would x plus 4 be equal to 0? So I do the opposite to solve for x, like we learned in 1.1, our first section. And we see x cannot be negative 4. And it's easy to check, is negative 4 plus 4 0? Yes. So I need to throw out negative 4. So just like on the last problem, anything in the entire world, every number ever invented works except for negative 4. So what we have to do is, let's just write that above so you can see. So this is how you would write it if they just asked you to write the notation. This is how you would graph x cannot be -4, but they're asking us for interval notation. So we put our infinities in. Remember, left end negative infinity, right end positive, and we just move left to right. And remember, order and shape of your brackets and parentheses match. So first we have a negative infinity, and we learned infinities always get parentheses when we did inequalities. And then it stops right before 4, but it never equals, whoops, not 4, but it never equals -4 because there's a gap in the domain. We have to use the u to say it's this interval and this. And then the second interval going left to right is -4, again with a parenthesis because we can't include -4 because it says right there, don't equal -4. So -4 up to infinity. Order matters, shape of the parentheses and brackets matter, so it has to be exactly like that. So just read your directions careful. So if it wants interval notation, that's the notation. This would be graphing the domain, and this would just be stating the domain. And I crossed out 8 originally, and then I thought, no, I want to do that one because I want you to see that it's not in this box. It's not a fraction. It's not a square root. So if it's not a square root, a fraction, or remember how I said eventually a log. So if it's not any of those things, that means it can be anything it wants to be. I could put -5 in there. I could put +5 in there. I could put 0 in there. I could put 1/2 in there. So it has no restrictions at all. So when there are no restrictions, which means the x can be anything in the world, what do you guys think you're going to write? Negative infinity to positive infinity. That's the whole number line. That means pick any x you want in the whole world and it works. Okay. So the other ones we will address later in other chapters. So that is the end of 2.6 for us. Okay, so I'll start 2.7 in the next video.